Welcome back to another science session. Today is Wednesday, April the 1st, 2020. Our lesson name for today is Particles on the Move. And our teaching point will be I can investigate and explain how the particle of a substance move in hot and cold water. So basically today we're going to be trying an inquiry activity to see on display what we have learned about wave particles, internal energy, and also heat in the last lesson and previous lessons as well. So I encourage you now to pause the video and write down the date, lesson name, and teaching point. And when you do that, let's continue. All right? So just like that, we get to our question of the day. Dash is a small portion of matter. Could it be motion, speed, body, or particle? I encourage you yet again to pause the video and try to come up with the answer on your own. Dun, 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 dun. And our question is particle. What is basically that? So a particle in physics, or actually in science, when we talk about a particle, we're talking about a small portion of matter. The word encloses an enormous range of sizes, from subatomic particles, such as electrons that we may find in atoms, to particles large enough to be seen, such as particles of dust floating in sunlight. All right. So basically, when we're working in models or experiments, and we don't actually want to come up with the real properties of that element, we just say that we're talking about a particle. So we just consider um, that object as a small portion of matter without considering its real size. All right? Our cognate of the day is radiation, which in Spanish would be radiación. So what is that? When we talk about radiation, we're talking about the emission or transmission of energy. So that means that we have energy transfer right there in the form of wave or particle through space or through a material medium. Since there's specifying right there that we need a space, actually a material medium to make this happen, that means that in outer spaces we don't have the conditions to communicate this radiation. We don't have the medium actually, then we can actually have this in outer space. So basically, as well as in sound, when we discuss on that lesson, we need a medium for those waves to travel through. I remember that when we were working on our lesson number 2, where we took a look at the visible light spectrum, we were talking about electromagnetic radiation. And right there, we just included radio wave, microwave, infrared, visible light, with the light we can see, ultraviolet, X-rays, and gamma radiation. So if we go back, right here we have the scale where radio waves are the smaller one, and then we got the gamma ray, actually the other way around. In the radio wave, we have the biggest wavelength, while in the gamma rays, we have the shortest one. And we have right there between 400 and 700 nanometers our visible light spectrum. Waves that are inside this spectrum are those that are possible for our eyes to be seen. Everything above 700 or below 400, then we cannot see them. Alright, we're still working on our last lesson on this module, which is heat. We're trying to come up with the answer for our session question, which is what is heat? So going back to our teaching point, let's revisit it. I can investigate and explain how the particles of a substance move in hot and cold water. So let's jump in right away to our inquiry activity. So if you open your book on page 64 specifically, that's the first one, we're going to see that we have an inquiry activity titled Particles on the Move. So, how does thermal energy move? If we revisit thermal energy, we might think about the internal energy that a body possesses, right? And it might depend on the kinetic energy. It is to say on how fast the particles inside that body are moving. So the more kinetic energy I have on that body, then that means that internal energy and thermal energy actually might be higher. So you just saw the sun hitting the road. Now you will investigate the movement of thermal energy in water. You're going to think about how a cup of hot water differs from a cup of cold water. How these differences relate to the motion of the particles in these two cups. So basically we're going to see how particles that we're going to represent using food coloring actually move in cold water and hot water. Probably for this activity you're going to need the help of an adult to assist you with the fire. Alright, so what materials are we going to use? We're going to need two clear plastic cups, we're going to need some cold water, and then we're going to need some hot tap water. Right there you may ask for an adult to assist you on. Then we're going to need a few permanent markers, a few sheets of white paper, blue and red food coloring, and an ice cube. Right? If you only have one color, let's say, you may continue with the activity anyway because it's going to react differently on the cold water and as the hot water as well. But what happens if I don't have any food coloring, right? Don't go crazy if you don't have the material right away. I wanted to I wanted you to give the chance to actually try this activity because I know that the coolest part of science is actually get to conduct experiments. But I know the circumstances that we are right now. So I understand that if you don't have them at home, then we can try it later on when we meet. Or you got the material. So right now you're supposed to make a prediction just before you begin your experiment. And that's the first step that we always take, coming up with a hypothesis. Alright? So what will happen when you add food coloring to a cup of cold water? What will happen to a cup of hot water? Alright? Keep in mind what we have learned about thermal energy and how the kinetic energy of its particles affected. Pause the video and get to answer this one in your science book on page 64. Alright, let's imagine that you already did that. And let's continue with the step of our investigation. So in our first step, you're going to use the marker, whatever color you want to try, to label a plastic cup as cold. You're going to fill the cup with cold water and you're going then to add an ice cube to the cup. Simple, right? After that, you're going to label the other plastic cup hot and you're going to fill that cup with hot tap water. As a third step, you're going to place both of the cups on a white sheet of paper. Let the two cups sit up for approximately 1 minute so the water can settle, right? Oh, Mr. Yo, I don't have white paper. Oh, you can try whatever kind of paper you want. At first, we're going to add 1 drop of red food coloring to the right side of each cup, alright? On the right side of each cup. And 1 drop of blue food coloring to the left side of each cup. So that means that in both cases, you are going to be trying both colors, right? So you're going to put 1 drop on the right, or from the red food coloring. Then you're going to try another drop on the same cup with the blue one. You're going to see how these two colors will react according to the temperature of the water. Then you're going to observe the cup for 5 minutes. And you're going to record your observations on the next page, where you will have a chart um, regarding to cold water and hot waters as well. You have a time frame of 5, 10, and 1 hour where you're going to write your observations. For example, let's say that in the cold water, in the first 5 minutes, an observation that I can say, for example, is the food color is slowly sank to the bottom of the cup and moved the liter. The red and blue did not mix much. The red stayed on the right and the blue stayed on the left. That is something that I have observed in the first 5 minutes. Then you're going to write your observation for the next 10, and then you're going to write your observation for an hour. So probably you're going to be pretty much engaged in this activity. After you do that, you're going to check your cups again after 10 minutes and after 1 hour, and you're going to describe what you see in each of the cups. Alright? So you should infer that particles move faster as the temperature of the water is increased due to the rate at which the food coloring mixes. So the faster that this food coloring mixes, and then that will mean that the temperature and actually kinetic energy and thermal energy are way higher, right? But you're going to see that after you conduct the experiment. And at last, on page 66, you're supposed to communicate your information, what you learned, what you discovered during this experiment. So you are going to have three questions, being the first one, in which cup did the particle move the faster? Red or, cold or, or hot? How do you know? And then you need to explain in detail what you notice on the fastest one, let's say. Did the results support your prediction? If we go back to the hypothesis that you just wrote at the beginning, then you need to compare this one with the result that you just got and say that the result whether supported your prediction or not. And yet again, you need to explain your answer. And just like that, we came to the end of the experiment. I hope that you can really enjoy this and actually can try it out because it's really cool to actually see this on display. Anyway, if you can't, um, later on I know that we were going to have the opportunity to try this, so I'll put an asterisk on this so I can keep it in mind. If you have any question or suggestion, you can leave it in the comments right below. So thank you guys. I hope that you enjoy and have a great day. Thank you.